Before any security-enabled device is released for production, it is critical to enable the password lock function. This setting is located in the zone header of either zone and is disabled by default. When password lock is disabled, password locations are always unsecure, regardless of whether the corresponding zone is locked or unlocked. In the top image in this slide is a CCS memory browser view of user OTP for Zone 1, starting at address 78,000. When a zone is locked, all user OTP memory locations are secure for that zone. Since the CCS memory browser reads device memory via an unauthorized source in JTAG, all secure memory locations appear as all zeros in the memory browser window. However, in this example, password lock is disabled, so the CSM passwords in each zone select block are unsecure and still readable via JTAG. This is useful during development in the event that passwords are forgotten or incorrectly programmed, but it also allows a hacker to read the CSM passwords and gain access to all secured memories if password lock is left disabled. To prevent this, password lock should always be enabled before releasing a device to production. This is a permanent setting, so it is important to verify that the CSM passwords have been correctly programmed and are not forgotten so that the user can unlock their zone. When JTAG lock is enabled, all JTAG access to the device is blocked. JTAG lock is enabled in the zone header, so it cannot be disabled after it has been enabled. To restore JTAG access, the user must provide their programmed JTAG passwords in the CCS OnChip Flash tool or UniFlash tool. If JTAG lock is enabled, the user must manually unlock the JTAG after each device reset to restore JTAG access. The bottom image in this slide shows a view of the CCS OnChip Flash tool's JTAG password GUI, which can be used to program the JTAG passwords. Unlike the CSM passwords, the JTAG passwords are split between the zone header and the zone select block. JTAG password high1 and JTAG password high0 are part of the zone header, while JTAG password low1 and JTAG password low0 are part of the zone select block. The lower portion of the JTAG password can be reconfigured whenever the link pointer is updated, similar to any other setting in the zone select block. As discussed in previous videos in this video series, the exe-only function is used to provide an additional level of security for confidential code. When exe-only protection is enabled for a memory region, all data reads or writes are blocked in that memory region, even if the data read or write is initiated from code secured by the same zone. To enable exe-only protection for a memory region, the user must first designate the memory region as secure via the grab RAM or grab sect fields in the zone select block. Then they must enable exe-only protection for that memory region via the exe-only RAM or exe-only sect fields in the zone select block. The only means of reading or writing to exe-only protected memory is by using the secure copy code function. The purpose of this function is to copy code from flash to RAM for faster execution without compromising code security. Details on using the secure copy code function can be found in the ROM code and peripheral booting chapter of the technical reference manual. Since data reads from exe-only memories are not allowed, you cannot calculate the CRC on content in exe-only memories using a CRC engine or software algorithm. However, in some safety-critical applications, the user may have to calculate the CRC even on these memories. To enable this without compromising code security, TI provides the secure CRC library functions for each zone. These functions perform CRC calculations in a highly secure environment. If the user does not wish to use the VCU for CRC calculations, they can permanently disable the VCU from calculating CRCs by enabling CRC lock in the zone header. Note that this is a permanent setting. If CRC lock is enabled, the secure CRC library function cannot be used. The Secure Flash Boot feature is a means of authenticating the first 16 kilobytes of flash before execution. This ensures that the application code has not been tampered with after getting programmed into Flash. Secure Flash Boot is enabled by modifying the GPReg fields in the zone header. Refer to the ROM code and peripheral booting chapter for more information on controlling boot settings via DCSM. In addition to modifying the GPReg fields, the user should program their own custom key in the CMAC key fields in the zone header. CMAC is a cipher-based encryption and decryption algorithm used on C2000 devices to authenticate the flash. The CMAC fields contain the cipher used in CMAC calculations. Using the CMAC key and the application code to be programmed, the user should calculate a CRC tag using the C2000 Hex Utility tool. This is a tool integrated into Code Composer, which can be accessed through the project properties. The Hex Utility tool will generate a .out file that contains the calculated CRC tag in a hard-coded location in the application code. Refer to the Secure Boot on C2000 device application note for detailed instructions on using the Hex Utility tool. If the user has followed each of these steps, the device will calculate a CRC tag from the flash contents and CMAC key fields during boot. If the calculated CRC tag matches the tag programmed in the user's .out file, the flash will be authenticated and the user's application code will begin executing. This concludes the DCSM Advanced Features video. Additional resources on DCSM can be found in any C2000 technical reference manual, as well as various application reports written on DCSM.